Hi everyone, today we're looking at question 8b of the 2004 unit HSC exam, or extension 2 as it's now called. It's the very last question of that exam, so in theory it's going to be a tough one. It's about probability, and probability is a tough topic at the best of times, so to have it as the very last question on a 4-unit exam is pretty rough. The question tells us that a fair coin is to be tossed repeatedly for integers r and s, not both zeros, so one of them or the other could be 0 but not both of them. Let the probability of r comma s be the probability that a total of r heads are tossed before a total of s tails are tossed. So that, or in other words, we're given that the probability of 0, 1, or the probability that no heads are tossed before a total of 1 tail, that's equal to 1, so that would definitely happen. And the probability of 1, 0, or the probability of 1 head being tossed before a total of no tails is 0. I think what that's really telling us is that because we're interested in the probability of the number of heads before some number of tails, well, if the number of tails is 0, then the number of heads is not before anything. So basically that's not a possible option. It is what really a probability of 0 means. And the probability of 0, 1 is basically saying, look, if you've got no heads before a tail, well, that can definitely happen. You can just you toss a tail, or you toss then 2 tails or 3 tails. Actually, the probability of no heads before any number of tails is going to be 1. So that's basically the setup. There's 3 parts to it, and I'll tackle each part in a separate video. So for this video, we're going to focus on part 1, which asks us to explain why for r and s greater than or equal to 1, the probability of r comma s is equal to half times the probability of r minus 1 comma s, plus a half times the probability of r comma s minus 1. Alright, so I've rewritten up what we're being asked to explain. It's a kind of unusual type of question, but, you know, basically we've just got to give some form of explanation as to why this relationship would be true. And I think it's a tricky one, but there is a little hint here in that we've got 2 items being added together, and in probability land, that when you see 2 things being added, that means they're 2 possibilities, and each of those possibilities starts with a half. And remember, we're dealing with a coin toss of a fair coin, so 50-50 chance of heads or tails. So what this really could represent is, say, a head coming up and then something, or a tail coming up and then something, and that would kind of get you to your addition, because they're the 2 things that could happen, say, on your first toss. So I think that's one way to think about this first part. We can say, well, how about we think about this as what happens on the first toss and then what must happen after that. So maybe if I define, say, outcome A as being the first toss is a head, I'll just say H, and then what that would mean is, so we would then need, well, if the probability of RS is R heads before S tails, and if we've already got 1 head, that means we need another R minus 1 heads to come before our S tails. So if that's kind of the way it's going, then the probability of A would be equal to the probability that we get our head times the probability that we then get R minus 1 heads before S tails. And given it's a fair coin, we know the probability of getting a head is a half. So we end up with just a half times the probability of r minus 1 comma s, which is this first bit here. So that's kind of a way to think about it. We've had our first toss, it's a head, so what then must have to come after that? And we can do a similar thing for this second bit that I'll just call B. So let's say for B, the first toss is the other possibility, which is a tail. So if that's the case, so we would then need, well, we haven't got any heads yet, so we still need R heads to come before, well, we've already got a tail and we need a total of S tails, so there's just S minus 1 tails to go. And that would then get us this R comma S, or R heads before S tails, if this is the way it played out. So like we did before, the probability of B would be equal to the probability that that first toss is a tail times the probability that you then got R heads before another S minus 1 tails. And again, fair coin means the probability of a tail is a half, so we end up with a half probability of R comma S minus 1. And so really what we're doing is we're bringing these together, because the first toss could either be a head or a tail, and then depending on what happens there, it determines what needs to happen after to end up in this territory. So we just add them up. That's why we have the plus here. So we can say, therefore, the probability of getting R heads before S tails must be equal to basically the probability of A plus the probability of B. So that's going to be a half times the probability of R minus 1 comma S plus a half times the probability of R S minus 1. And that's as required. That's basically what we were being asked to explain. So I think this is a valid way to explain it. I don't think it's not like, it's a mathematics exam still at the end of the day, so it's not like we're writing out essays or anything, but it's just kind of using some level of wording to explain that you understand why this relationship basically holds true. And I think the hint there was seeing that each of the items that we're adding started with a half, and then you could kind of interpret that to mean, well, maybe it was a head or a tail, and then what has to come after if those are the two options for the first toss. So there you have it for that part one. Not a huge amount of work, but I think quite a difficult question to grapple with. I think I could imagine a lot of students struggling with that, maybe perhaps not knowing where to start, particularly with the way this question was worded and kind of knowing what's important and what's not. You could see this one stumping a lot of students, especially given it's the last question of the exam, and it's about probability, which is a daunting topic. And you know, you're probably tired after however many hours of working through all the other questions to then have to try and get your head around this. But I think this is a way to tackle it, so hopefully you were able to follow along with that and it all made sense. And now I'll follow up in another video to work through part 2 of this question. All right, tick boom.